Hello, Math 005. This is your very last section of this course, and it's 5.7 polynomials and several variables. This is going to be adding, subtracting, multiplying the polynomials just like we've been doing the past couple sections. The only difference now is we have more than one variable in each given problem. Everything we worked with before, there may have only been x's. I mean, you'd have different exponents, but now we're having more than one. Example 1, evaluating the polynomial. This problem is going to be very similar to things we've done in the past, where you're taking values, substituting them into a polynomial, and then evaluating it. Here we're substituting in a -2 for x and a 5 for y. Keep in mind, anytime you substitute a negative in, you have to make sure you put parentheses around it or it will goof some things up, especially when we start working with exponents. So we get 4 plus 3 times x, which is -2, and we're adding xy squared. So this would be x, and then the y is 5, and then that's being squared, plus 8, and then x squared. So again, that would be -2 squared, and then y is 5. So we have, and then 5, and that value is going to be cubed. So now what I want you to do, pause the video here and type it into your calculator. Type it into your calculator, you should get 3,948. If you did not get that, go back, make sure you put parentheses around your negatives, and you have your exponents all typed correctly. All right, example 2. Surface area of a right circular cylinder is given by the polynomial 2 pi rh plus 2 pi r squared, where h is the height, r is the radius. A 12-ounce can has a height of 4.7 inches and a radius of 1.2 inches. Approximate surface area to the nearest tenth of a square inch. So what we're doing here is we're taking this formula, our 2 pi rh plus 2 pi r squared, and we are substituting values in for our r and for our h. It tells us that the height is 4.7 inches and tells us the radius is 1.2 inches. So we just need to take those values and substitute them in. So we have 2 times pi times our r, which is 1.2 inches, times our height, which is 4.7 inches, and we're adding that to 2 pi and then r squared, which would be 1.2 inches squared. Again, we're going to use our calculator to evaluate this. We want to just be careful with the units here. So I'm going to do this one in two parts. I'm going to start by multiplying these three things together, and then, or four things rather, and then I'm going to multiply these things together. When you use the pi in your calculator, you want to use the second and then the exponent button. You'll see the pi sign. That way we get the exact value. We do not want to use the 3.14 approximation. So we type in our calculator 2 pi parenthesis 1.2, another parenthesis, and then 4.7. And when we type this in, we are getting a value that is approximately, I'm just going to write this down, but I'm going to make sure I use my calculator for the exact value, 35.44. And then since we have inches times inches, this would be inches squared. And then we have 2 times pi times 1.2 squared, which gives us approximately 9.05, again, inches squared. Now we want to add these two values together. What I'm going to do on my calculator is scroll up and choose the values that I've already found. That way I don't have to worry about goofing up the approximations. And we're getting something to near, tells us the nearest tenth. So this would be 44.5 inches squared would be our final answer here. Okay, moving on to the next problem. It says, what is the degree of the term? Keep in mind, degree is the number of variable factors. So we want to answer how many variables are in this problem. Well, we have an x, we have 2 y's, and 3 z's. So altogether we have 1, 2, 3, 4, 5, 6. So here the degree would be 6 because it's how many variable factors. We're moving with that into what we call like terms. Now we know that x squared and x squared would be like terms, or y cubed and y cubed. But now we're talking about more than one variables here. It tells us that like terms, they have exactly the same variables with exactly the same exponents, or are constants. So what this means, like terms, if we go up to this one that we have above, this negative 14 xy squared z cubed, a like term to that would be something that has x, y squared, z cubed. So you could have, we'll say 1/2 xy squared z cubed. That would be a like term. Something that would not be like is if you had, we'll just say 3xy cubed z squared. If you look at this, you still would have a degree of 6. However, it does not match exactly because there's the different number of exponents. So you want to be careful with that. The other thing you want to be careful with like terms is sometimes the order might be different. So for example, you might have negative xz cubed y squared. Even though the order between this and this is different, you can still see they both have 1x, 3 z's, and 2 y's, so therefore they would be considered like terms. Okay, so now we're just going to work through a couple examples. The first one, we're going to subtract. Just like we looked at in a couple sections ago, you have to get rid of the parentheses. So in this first one, you have to distribute a positive one. The second, you have to distribute the negative one. So when we do this, we get negative 5x cubed plus 3y minus 5y squared. Now we have to distribute this negative 1, which what it does is ultimately changes the signs inside the parentheses. So plus 8x cubed plus 4x squared minus 7y squared. And now we want to combine like terms. Let's start with x cubed. So we have a negative 5x cubed plus 8x cubed, which would leave us with 3x cubed. Let's see, let's look at our, do we have any other x's? Yes, we have a 4x squared. So let's add our 4x squared. Now let's go over to the y's. We have a 3y, so plus 3y. And let's see here, last but not least, we have y squares. So we have negative 5 and negative 7, which would leave us with a negative 12y squared. And that would be our answer for that one. Okay, so that's going to be our subtraction. Now we're going to be looking at multiplying. So since this problem here, we have two binomials, that's when we can use the process of, like we talked about in the last section, of foiling. So we can multiply the first two terms, which would be p times 2p, which would be 2p squared, and then the outside 2, which would give us negative 3 qp. The middle two would be plus 5 qp, and the last ones would be negative 15 q squared. Now looking at the middle two, this is where the order might trick you or just kind of throw you off a little bit. You may have thought negative 3 pq. Keep in mind, those two things would be the same kind of terms because they both have a q and a p with them. So just to simplify this, we have 2p squared. This would be plus 2pq minus 15q squared. Okay, now what I want you to do, I want you to try example 6. Keep in mind what it means when you have something being squared. If you need to, look back to your notes of 5.5 and look to see what happens when something is squared. Go ahead, pause your video, try it out, and then check your answers with mine. Okay, you should get a to the 6th, negative 14 a to the 5th b, plus 49 a squared b. Keep in mind, when it's being squared, that means there are two of these. Well, means there's two of them. And then you can use the FOIL again. So we did the first, a cubed times a cubed. Also keep in mind, back to your exponent rules from the beginning of this unit, a cubed times a cubed. That's when you add the exponents. So we get a to the 6th there. Also, if you want to think of this in another approach, we have to take the first one, or I'm sorry, let's go back. You have to take the a cubed and distribute it to this whole thing. And then you'd want to take the negative 7a squared b and distribute it to the same thing here. And then you'd end up getting this, and then you'd simplify it to still get that. Either approach works just fine. Okay, well, that completes everything for this class then. Good luck on your homework. Again, as always, reach out if you have any questions, and I'd be more than happy to help. Have a great day. Bye.